Like we were saying in the last module, mutabilities of lists are extremely important. We already saw what is a list, what we can do with a list, and also how data analysts use lists. Unlike strings, which are immutable, lists are mutable type. That means they can change. We can change their content. For example, if we initialize a variable called cubes and turn it into a list with the elements 1, 8, 27, 65, and 125, then we can find out the cube of 4. We can also replace the wrong values. For example, we have the list cubes, and then we want to replace the value on index 3. Remember, the list starts with index 0. So if we replace a value 64 on index 3, then we'll get the list 1, 8, 27, 64, and 125. You can also add new items at the end of the list by using something called append. Append, as we will see later when we study function, is a method. We will see more about methods later. If we have the list cubes and we want to append 216, which is a cube of 6, then cubes will have an added element in the list. Please compare the list at the beginning of cubes here on the first example with this one. As you can see, 216 is in 1, 2, 3, 4, and 5th, index 5. Normally, append items will go at the end of the list. There's different things. You can manipulate lists by using certain methods that can be doc suffix to the list name for the manipulation. We already saw append. Append adds an item to the end of the list. You can also extend, insert, remove, pop, index, count, sort, and reverse a list. All of these are called methods. Slicing and dicing is easy. Assignment to slices is also possible, and these can even change the size of the list or clear it entirely. Of course, think about it. If you're dicing something, you're making it smaller. Or you're slicing something, right? You're going to try to make it smaller. The new list will be smaller. Or you might have a bigger list if you're trying to append items. For example, in the example letters, we have a series of strings with the letters A to G. Now we can replace some values. Remember about indexing. If we wanted to index or replace some values that go from index 2 to index 5, with these values, then remember we start 0, 1, and 2. So we will begin slicing over here on C with the new values. The new values will be replaced. And then F and G will stay the same from the original list. You can also clear the list by replacing all the elements with an empty list. Remember that for all elements we use the semicolon and we leave empty both sides. That will create or clear or delete a list. We can also, using the built-in function length, that we used before in Python, knowing how many elements are in a list. The number of elements on a list, we'll use the function length, and then of course inside we'll write the name of the variable or list, in this case letters. Length letters give us 4 because we have 4 elements in the list: A, B, C, and D. It is also possible to nest lists or create lists containing other lists. Believe it or not, this can start to get very complicated as we go along. Just because you really have to keep in mind the original list. In this case, they gave us 3 lists: A, N, and X. When you're nesting, you have to be careful that you're transferring the right values or elements into the right place. As you can see, list end has A and N. If we want to know the index of the element 0 on X, and here we want to know what is the first element of 0 and 1, that would be B. This is an example that I found online about how to count elements, and also on the list, if you wanted to know what element is at index 0, that would be apple, of course. At element 1 will be apricot, and so on. If you wanted to do a sublist, or what is called dicing or slicing a list, to create a new list from element 1 at index 1 to element at index 4, then you will get apricot, banana, and coconut. Remember that an index is not the same as an element position. And remember, the list begins with index 0. Now you can practice on how to create and manipulate lists with the examples that I provided before. It is important that you always do these examples on idle. That way to give you practice. You can just practice on idle, or you can save the code for later on. In the next module, we're going to cover functions and methods. I hope to see you then.